This is tutorial lesson 9.4. We are looking at aromatic compounds. One of the key things with aromatic compounds is this C6H6 ring known as benzene. It has 6 carbons. You can see here numbered 1, 2, 3, 4, 5, 6. Each one has a single and a double bond, meaning that you will have hydrogen attached to each one of these as well to make the benzene ring of C6H6. It doesn't really matter where you put your double bonds if you're showing it with double bonds. As you can see, you're going to wind up with the same configuration. Now, in fact, these electrons are just zooming around and around and around. They can find all over the place. That's due to some of the nature of what an electron is. And so we actually symbolize benzene with the circle because these double bonds are made up of 6 electrons, which are evenly distributed around the whole benzene ring. Now, if we are naming benzene compounds or aromatic compounds, because most aromatics, over 99%, contain the benzene ring, we would use that as a parent chain. So here we've got a parent chain of benzene, and we've got 2 branches, 1, 2. They're both methyl groups, so that's dimethyl benzene. Now, what we're going to do is we're going to pick the numbering system which will allow this to have the smallest numbers. Now, in this case, it doesn't really matter because no matter, you'll start with one of them and work your way around. It doesn't matter if you go this way or if you go the other way around, you're still going to wind up with 1,4-dimethylbenzene. If you have a case where you have 2 distributed things around benzene, we can use ortho, meta, or para, which is a 1,2, a 1,3, or a 1,4 distribution around a benzene ring. So for example, if we had ortho dimethyl benzene, right, they would be side by side. Doesn't matter where because this is symmetrical. It could be sitting here, or it could be sitting here. Doesn't matter where it is, or it could be sitting here. The fact is that they're just sitting next to each other. They're in a 1,2 configuration. The meta configuration for dimethylbenzene would be being separated by a single carbon, right? So this carbon here is showing separation between these 2 methyl groups, and that is the meta positioning. The para positioning will be in the 1,4, meaning that they are across from one another. It really doesn't matter where you start and where you end. This is the para position for para-dimethylbenzene. Let's take a look at another one. 1-ethyl, 3-methyl, so this would be the meta position as well. You could say this is meta-ethyl-methylbenzene, but either way, we've got the ethyl group in position 1, and we've got the methyl group in position 3. Sometimes it is better to use the phenyl group for a benzene ring as opposed to saying benzene. This is when the benzene ring is a branch, which means if we've got 6 or more carbons attached, we're looking more as the benzene is actually as a branch, such as here where we've got 2 phenyl octane. Here you've got your octane chain, and you see on carbon 2 you've got a phenyl branch. And so this branch here is on carbon 2 of the octane. Let's take a look at this one here. As we can see, we've got a parent chain running here, 5 carbons long. This is pentane. So we marked parent chain pentane. On carbon 2, we've got a methyl and a phenyl group. So we would call this 2-methyl, 2-phenyl pentane. We notice that we put these in alphabetical order because they are both hydrocarbon branches. Here, second example, we've got 2-methyl 3-phenylbutane, so parent chain is butane. On carbon 2, we see a methyl group. On carbon 3, we see the phenyl branch or that benzene ring. And we can fill in the rest with the hydrogens as it's a butane. It's an alkane, means a saturated compound. We do have a few common names for benzene compounds. Here's a look at most of them. There are 3 here. The phenyl group is one that is very common within our course. Toluene is also very common within our course. That is just a methyl benzene, where this has an alcohol or an OH functional group in the phenyl. Third one is xylene, which in this case we have the ortho configuration, meaning it's in positions 1 and 2. You could also have metaxylene in the 1,3 or paraxylene in the 1,4. Thank you for watching.